Hello, everyone. Welcome back to another video. Today, I intend to talk a little bit about a math principle and solve a couple problems. As you may have seen already, as provided in the title, it's about the pigeonhole principle. This is not taught at the high school level, but I'm sure some of you already are familiar with it. It's a principle that seems quite obvious but proves as a powerful tool in cracking some intuitive problems. Then, without further delay, let's dive into it. The definition in simple terms: if n pigeons are put into m holes with n greater than m, then at least one hole should contain more than one pigeon. Well, that's more like common sense, isn't it? Basically, if you have more items to be put in a fewer number of boxes, you'd end up having some boxes with multiple items. That's the beauty of it. To better visualize this, let's use an example. Say we got 4 holes and 5 pigeons. Now, if you put pigeons into each hole, as you see, you'd end up with 2 pigeons in one hole. To be clear, there are many ways you can allocate these 5 pigeons into the 4 holes. Just look at these scenarios. There can even be multiple holes with more than one pigeon. The principle specifies the least condition in this case, that at least one hole would have more than a pigeon. Alright, I hope you understood that. Now I'll quickly walk you through 2 problems. Let's see how interesting this can get. Problem 1. Prove that if you choose 7 distinct integers from 1 to 12, there exists at least a pair whose sum is 13. When it comes to these types of problems where pigeonhole principle looks like a way forward, it's always best to think about how to arrange your stuff corresponding to pigeons and holes. Let's start by thinking about the different ways you can choose a number pair, such that they add up to 13. There's just 6 different possibilities as you see here. Now, whatever the 7 numbers you are going to pick, they have to be from these 6 groups, right? Because the 6 groups fully contain the 12 numbers you are allowed to pick from. Hence, with this analogy, it should make sense that the 6 groups are your holes and the 7 numbers are your pigeons. Therefore, from the pigeonhole principle, you can conclude that you'd have to pick at least 2 numbers from the same group, and those 2 numbers will add up to 13. Proof completed. Let's quickly look at an example. Suppose you'd have picked your first 6 numbers this way, 1 number from each group. At this point, you still don't have a pair adding up to 13. Now, you can pick the 7th number from any of the groups. Suppose you pick it from the first group, then 1 and 12 adds up to 13. You pick it from the third group, then 10 and 3 add up to 13. If picked from the 5th group, 8 and 5 add up to 13. So it's pretty clear that there will be a pair that adds up to 13 for sure. Alright, that was an easy problem. I hope you understood it well. Now let's look at the next one. Problem 2. 5 points are chosen inside an equilateral triangle of side length 2. Show that there's a pair of points whose distance from each other is at most 1. If you look at this triangle, there's an infinite possible ways to place 5 points inside it, isn't it? Here, first you should realize that the 5 points correspond to the pigeons. Next, you need to define what the holes are. Intuitively, the number of holes has to be lesser than 5, preferably 4. So if you divide this triangle into 4 smaller triangles as I've done here, we can term those as the 4 holes. Each of these would be an equilateral triangle with side length equal to 1. Now, we have 5 points and 4 triangles. So from the pigeonhole principle we can conclude that there's at least one triangle containing 2 points inside it. However, we still need to go a step further here, to prove what the question asks. Just isolate one triangle out of the 4 like this. Let this be the triangle which would contain the 2 points within that we showed earlier. Let these 2 red dots denote the 2 points. As you can see, the 2 dots can be anywhere inside it, but the maximum distance between them would occur only if they are placed at the vertices of the triangle. Hence, the maximum distance between the 2 points would be 1, so that answers our question. There will definitely be a pair of points whose distance from each other is at most 1. Hope I was clear. First, with the pigeonhole principle, we showed that there's a pair of points inside one of the triangles, and then we showed that they are placed apart at a distance of 1 at most. Okay, that brings us to a conclusion. Here, I have included 3 other problems that aren't too hard for you to try. Comment your answers below. I'd love to hear your overall feedback as well. I hope this video helped you admire the beauty of this principle. Don't forget to like this video and drop a subscribe to my channel. Have a nice day. Goodbye.